Active galactic nuclei, the topic of this video, are powered by black holes that do things. That's what makes them active. An active galactic nucleus, or an AGN, is essentially a very bright core at the center of a galaxy that's powered by a supermassive black hole and its accretion disk, the gas and dust that orbit it. AGNs produce intense winds, jets, and lights on basically every spectrum. They're so important to the formation of their galaxies that they're referred to as galaxies. We're going to take a look at the top three: Seyfert galaxies, radio galaxies, and, of course, quasars. Seyfert galaxies were the first AGN to be discovered by Carl Seyfert in 1943, who noticed how a few nearby galaxies had weirdly bright centers. They look basically like a typical galaxy except for that bright core, which is, of course, its active nucleus. Seyfert galaxies are characterized by their strong emission lines that fall within the visible light spectrum. The closest one to us is NGC 4395, which is 8 million light years away. Like the Milky Way, it's also a spiral galaxy. Radio galaxies are, unsurprisingly, named for their extremely strong radio waves that they emit. They were initially found on accident during World War II when radar operators picked up on their radio signals. However, it took about another 10 years to really discover what they actually were. If you and I were to look at a radio galaxy through a normal telescope, it would look to us just like a very bright star. That's because you and I don't see in radio waves. However, if we were to look through a radio telescope, we would see something pretty odd. A radio galaxy through a radio telescope looks like a small bright point in the center with two thin jets on either side that lead to two enormous lobes of radio waves on either side. Giant radio galaxies are enormous, with the largest known one at least 16 million light years across. The most well-known and most powerful type of AGN are quasars. A quasar is a galactic core so bright that we can't see the galaxy that surrounds it. The core is about the size of our solar system, but have been found up to 100,000 times brighter than our Milky Way. They're also incredibly far away. The closest ones are hundreds of millions of light years away. That means that when we see them, we're not seeing them as they appear right now, but as they were a very, very long time ago. Because of this, we believe that quasars were a feature of the earlier universe, when colliding galaxies turned those extra powerful black holes into what we see today. Scientists use quasars to learn more about this early universe and what was going on back then. In sum, AGNs are super powerful and super cool, and scientists love to learn all they can about them. Thank you.